to my presentation on the Higgs boson, and it's in the series Physics in a Nutshell. Let's begin. Okay, so the history of the Higgs. It was first suggested in 1964 by Peter Higgs and his other colleagues in the Physics Review, Broken Symmetries and the Masses of Gauge Bosons. The scientists didn't take this very well. They didn't think he understood the physics he was claiming. CERN rejected it, and not many scientists believed in him. Proving the Higgs boson exists has been a lot of money, and it's took a long time to accomplish it. All the experimental work is being completed at the Large Hadron Collider. Confirmation of its existence was on the 4th of July 2012, where two independent detectors at CERN both relayed their information, their results, and they related 4.9 sigma and 5 sigma, and this means for 5 sigma it's 99.999% positive that the Higgs boson exists. And there is a picture of Peter Higgs. So what is the Higgs boson? It is a gauge boson that mediates the Higgs field. So the Higgs boson's job is to interact with particles to give them mass. It occurs now, and it occurred in the early universe where the particles were all travelling at the speed of light, and the Higgs field condensed out. The Higgs bosons interacted, slowing them down, giving them mass, differentiating between the particles, and hence giving us stable atoms. And there's a nice little picture of a CMS detector where they fired two protons together. Okay, so what is the Higgs field? The Higgs field is a scalar field which permeates all parts of the universe, and it's mediated by the gauge boson, the Higgs boson. Depending on the particle means if it gains mass or not. Here are three examples of particles: my photon, electron and top quark. The photon has no interaction with the Higgs field and it travels at the speed of light. The electron has the weakest interaction and the top quark has the strongest interaction. Okay, so the basics of the Large Hadron Collider. So there's hydrogen atoms are added to the source chamber. They are stripped of their electrons, making them protons, and they're accelerated by an electric field. These are accelerated to 1/3 times at the speed of light. The protons are put into a circular booster, splitting them into 4 lanes, and the electric field is pulsed, increasing their speed to 91% the speed of light. They're then put into a proton synchrotron, which reaches 99% the speed of light, where it gets so fast that the energy you put in doesn't go to increasing its velocity, it goes to increasing its mass. Because that's what happens at very high speeds when you get close to the speed of light. Then they enter the Large Hadron Collider. It consists of 2 pipes. The protons go clockwise and anticlockwise. They use a special system which I'm not fully 100% how it works, but they send it so none of the protons hit each other until they want them to do, and it's a very sophisticated piece of equipment, and that's how they do it. They enter the Large Hadron Collider. They keep adding more and more energy to make it even faster, but even more gaining weight. And then eventually they collide when they decide they want it to, and 2 protons released a massive amount of energy, something of TeV, I think about 2 teravolts, which is a massive amount. And there is a picture of CERN, and once they collide they analyse what is left, and they analyse for the Higgs boson, but that decays away into other particles and they analyse it from that. Okay, so that was quite complicated. If you want a simplified version, here it is. So here is my Large Hadron Collider. Here are my protons, and they're going to collide. We send them on the course. So at some stage they collided. The protons disappear, and this is what you would get. And where they collide is in the centre here, and that's the debris. So they spin around, the magnets push them into contact, and then they collide. So I like to know about applications. So what are the applications of the Higgs boson? The applications are not fully known at the moment. When we discovered electricity, it took them over 90 years to fully understand how electricity works, and it's one of its first applications was the battery and the light bulb. So you know what I mean, it's quite a long stagger stage from once you discover something to find a useful application of it. Just think about astronauts going to the moon. It took us over 400 years for that to happen, so you know what I mean, it takes quite a long time. But in theoretical terms, there are some applications we could do in theory. So since the Higgs boson gives its mass to attributes like inertia and gravity, we could control the mass of inertia. So if an aeroplane like this one, which could weigh 200 tons, if we could control the mass, make it 20 tons, then we can control the amount of fuel we use, save on fuel, it boosts the economy, so there's a useful application of the Higgs boson. Okay, so that's all I want to speak about today, but thank you for watching and I hope you enjoyed.